Alright, this is our third video on substitution, and this video is going to talk about different kinds of problems you could see that involve substitution and different solutions that we could see. So our first question says, if 6x plus 2y equals negative 14 and y equals 5x plus 1, then what is the value of x? The first thing that we should be doing is we should be using cups. So I'm going to go ahead and circle the question, then what is the value of x? So this question is not asking us for the ordered pair our typical solution would be. It's asking us only for the value of x. To remind myself of that, I'm going to go ahead and put at the top of here that x equals. This is what my answer is going to be. I'm only looking for the value of x. So what is x? I should see, if I'm reading this question on a test or on an exam, I should look at this and I should see that I have two equations, and in my head I should be thinking two equations, systems. What kind of methods do I have to solve systems? Well, I can use graphing, I can use substitution, and we can also use elimination, which we haven't talked about yet. This equation is the best to use substitution because one of our equations is already solved for y, and we can substitute that in for y. So I'm going to go ahead and rewrite these two equations. 6x plus 2y equals negative 14, and y equals 5x plus 1. Now I know I'm going to need to solve for x, I'm going to need to solve for y, and then I'm also going to need to check my solution. So I'm going to set this up. I know that y is going to equal 5x plus 1, and then I'm going to use my first equation to solve for x. 6x plus 2y equals negative 14. Now, if I were you right now, I would go ahead and solve this on my own. You should know how to solve this by now. So pause the video, try solving this problem on your own, and then you can resume just to check that your answer is correct. So since I know that y equals 5x plus 1, I can go ahead and substitute this whole thing in for y. So 6x plus 2 equals negative 14. The value of y was 5x plus 1. I'm going to go ahead and distribute. I have 6x plus 2 times 5x is 10x. 2 times 1 is 2. I notice I have some like terms. I have a 10x and a 6x. It's going to give me 16x plus 2 equals negative 14. Now I see that I have a two-step equation that I can solve. I'm going to go ahead and bring over my plus 2 to the other side by subtracting it. I now have that 16x is equal to negative 16 because negative 14 minus 2 is negative 16. If I want to solve for x, I'm going to divide both sides by 16, and I get that x equals negative 1. Alright, now I could right now, I could go up here and write x equals negative 1. But the chances that I made a mistake are there, and in order to truly make sure that this is the correct answer, you should go ahead and very quickly figure out what y is and check your solutions. That's going to ensure that you have the right answer. So I'm going to go ahead and still find y. I'm going to substitute in x. And let's see, negative 5 times negative 1 is negative 5. And negative 5 plus 1 is negative 4. So I just found out that y was negative 4, that x was negative 1. Normally, I would write my solution like this, negative 1, negative 4. This would be my solution. We're only looking for x, so your answer is that x equals negative 1. To make sure that I'm right, I'm going to go ahead and check it, and that's why we had to solve for the y. So let's see, 6x plus 2y equals negative 14. And my second check is going to be y equals 5x plus 1. Just to make sure, my value of x was negative 1. My value of y was negative 4. And if we go ahead and we put this into our calculator, 6 times negative 1 plus is negative 6, plus 2 times negative 4 is negative 8. Negative 6 plus negative 8 is negative 14. That check works. Let's try our second one. Y equals 5 times x. So the value of x was negative 1. I forgot to put in my y. That's a big mistake a lot of us make when we're checking. We're going to put in a negative 4 for y. And let's see if that gives us negative 4. 5 times negative 1 is negative 5. And negative 5 plus 1 is negative 4. My check worked. So, since I got both checks worked, I'm not going to write my solution as an ordered pair. The solution is -1. The value of x is -1. All right, let's do another example. It says, what is the solution to the systems of equations below? So using cups, what is the solution? Okay, I'm looking for a solution set to the systems of equation below. Now I should look at this system and I should say, oh, it's a system. I know that I can use substitution, I know I can use graphing, and then later on we're going to learn about elimination. Right now we're talking about substitution. And so I'm looking at this and I'm going to say, okay, I need to have one of these equations solved for either x or y. Which one will be the easiest to solve for? And I notice that this has a +1 as a coefficient. So I'm going to go ahead and solve this second equation for y. In order to do that, I need to bring over my 2x. So I'm going to add 2x to both sides. These cancel out, and I'm going to be left with y equals, I can't do -1 plus 2x, so I'm going to have y equals 2x minus 1. Notice that I put the 2x first, and that's just because I wanted it to be in y equals mx plus b, and that's a little bit easier for me to write it out that way at first. So, essentially what I just did was I changed this equation into y equals 2x minus 1. We're still using the full top equation. We're not rearranging it. I have a -6x plus 3y equals -1. I'm going to go ahead and erase this work right here of rearranging so we have a little more room, so copy it down if you need it. So now the two equations that I'm going to use to solve this system are y equals 2x plus -1, which is this rearranged, and -6x plus 3y equals -1. So I know I'm going to need to solve for x, I'm going to need to solve for y, and I'm going to need to check my solution. So what is the value of x or y? Y is going to be 2x minus 1. And I'm going to use my top equation to solve for x. -6x plus 3y equals -1. Okay. Now, I know that y equals 2x minus 1, so I'm going to substitute in that for y. 2x minus 1 equals -1. I see that there's some distributing I can do, so I'm going to go ahead and do that. -6x plus 6x, because 3 times 2x is 6x, and 3 times -1 is -3. I notice that there's some terms I can combine, a +6 and a -6. Now, if I do on my calculator, -6 plus 6, I get 0. Essentially what that means is that we have no x's. We have no x's. We really just have 0 left. I'm going to just keep it as a 0 because I have no x's, so I don't need to put an x. -3, bring down my -3, is going to equal -1. 0 minus 3 is -3. Now, we get to this point, we have no x's left. What is the solution if we have no x's left and we have a statement like -3 equals -1? Alright, so I'm looking at this and it says -3 equals -1. That is a false statement because -3 does not equal -1. Because this is a false statement, the solution to this system is no solution. Because this is false. And you can assume it's no solution because -3 equals -1, but I want us to go through and understand why it's no solution. So first of all, if it's no solution, when we graph our two equations, they should be parallel lines. They should never touch each other or never intersect. The easiest way to tell that is to take this first equation and to rearrange it into y equals mx plus b and make sure that it shares the same slope with the second equation. So I'm going to go ahead right now and I'm going to rearrange this second equation so that it's y equals. So I have -6x plus 3y equals -1. In order to solve for y, I need to bring 6x to the other side. Now I have that 3y is equal to -1 plus 6x. I need to get the 3 away from y, so I'm going to divide both sides by 3. Now I'm left with y equals -1/3 plus 2x. I'm going to rearrange this so it's in y equals. So y equals 2x minus 1/3. So let's look at our two equations. I can see right now they share the same slope. But let's graph them so you can really see what's going on. I have y equals 2x minus 1, and y equals 2x minus 1/3. Let's go ahead and graph the first one. I have a y-intercept of -1 and a slope of positive 2, so I'm going to go up 2 over 1. Go ahead and draw my line. So here's my first line, y equals 2x minus 1. I'm going to go ahead and graph my second line, which has a y-intercept of -1/3. It's going to be a little hard to see, so I'm going to assume it's right about there. And our slope is positive 2 over 1. So I'm going to go up 2 over 1. It's going to go right there. Up 2 over 1 over 1. I'm going to go ahead and draw my line. Alright, now these two lines are pretty close together, but if you look, you should notice that those lines are parallel lines. They never touch. That is why it is no solution. These two lines will never intersect one another, and because they never intersect, their solution will be no solution. The easy way for you to check that, if you are solving for x or y and you end up getting something like -3 equals -1, is to go ahead and rearrange your other equation. Once you rearrange them, if they share the same slope, these two equations both share the slope 2x. That is a way to confirm that the solution is no solution. So what is the solution to the system of equations below? We won't have a solution like this. It's not one solution. Our solution is no solution. All right, let's do one more example. All right, so one more example that says, which of the following ordered pairs, which is a solution to the systems of equations below? So I know I need my answer to be an ordered pair. It's asking me what is the solution to the system. I know this is a system, so I'm going to have to use either graphing, substitution, or elimination, which we're going to learn at a later date. So I'm looking at these two, and I don't have a graph, so I'm going to use substitution. And I'm looking to see, okay, are either of these equations solved for x or solved for y? Neither are. This is solved for a negative x, which, even though it's a negative, this will be pretty easy to rearrange. So I'm going to go ahead and I'm going to rearrange this one so that it's x equals. So right now I have negative x equals -2y minus 9. I know that I can't leave x as a negative, and I know that it has a -1 in front of it. I'm going to divide both sides by -1. So that's going to leave me with x equals -2 divided by -1 is a positive 2y, and -9 divided by -1 is a positive 9. So I'm going to go ahead and erase this work so that we can rewrite this equation, so copy this if you need it. The new equation that I have is going to be x equals 2y plus 9. And then I also have this equation that I'm leaving the same, which is 3x minus 6y equals 27. Let's go ahead and let's set up solving for y, solving for x, and checking our answer. So I know that x is going to be equal to 2y plus 9. I know that this is going to be equal to 3x minus 6y equals 27. If x equals 2y plus 9, I can substitute that whole thing in for x. So I'm going to have 3 minus 6y equals 27. I have 2y plus 9. Going to go ahead and distribute. 3 times 2y is 6y. 3 times 9 is 27. I notice there's some like terms I can combine. I can combine my 6y with my negative 6y. Well, just like before, when I combine those, it's going to give me 0y. So I essentially have 0. I'm going to bring down my plus 27. 0 plus 27 is just 27. And right here, I've ended up that 27 is equal to 27. Now, this is a true statement. That is true. 27 does equal 27. So what does that mean? If you end up that you have two numbers and they equal the same thing, like 27 equals 27, what that means is that the solution is infinite solutions. Infinite solutions. The reason is that essentially these two equations are the same. Although they don't look the same, if we rearranged them, they would look the same. So the best way to check that that's actually the solution is to rearrange the other equation. We've already have this equation rearranged so that y equals 2y plus 9. So I'm going to go ahead and take this second equation and I'm going to rearrange it and solve for x. So I'm going to go ahead and erase this work so I have a little bit of room. So I have 3x minus 6y equals 27. If I were to rearrange for x, I would first get rid of the 6y. Now I have 3x equals, I can't do 27 plus 6y, so I'm going to go ahead and just write it out. I need to divide both sides by 3. I'm going to have that x equals 27 divided by 3 is 9, and 6 divided by 3 is 2. Now I'm going to rewrite this so that the y comes first. I have x equals 2y plus 9. You should notice that these two are the same. This equation rearranged to solve for a positive x is 2y plus 9. This equation rearranged to solve for a positive x is x equals 2y plus 9. These are the same equations. If we were to graph these equations, if they were y equals, they would look the exact same on the graph. Because they are the exact same, the solution is infinite solutions. Alright, those are the different kind of cases you might see in substitution. There's no practice for this, but go back through, make sure, review your notes, and make sure if you have any questions to write them down and have them ready for class.